Hello, I'm a 9th grader and this is my science fair project, Bioassay Test Part 2. What is the amount of adsorbent for each lead concentration that helps early seedling growth? Freshwater scarcity is a significant issue for agriculture in developing countries. To meet water requirements, farmers are now using industrial wastewater, which usually carries pollutants like heavy metals. Heavy metals tend to bioaccumulate in crops, and once they enter into the food chain, they can cause serious health threats. Lead is one of the main pollutants that can accumulate in plants from various routes, including air, water, and soil. There are different ways to check for these toxicities, such as atomic adsorption spectrometry, ICP-OES, and a bioassay, which is a test for pollution that uses plants or other organisms to assess the toxicity of the sample. Various methods of remediating metal-polluted soils exist. They range from physical, chemical, and biological methods. Most physical and chemical methods, such as encapsulation, solidification, and stabilization, are expensive and they do not make the soil suitable for plant growth. On the other hand, bioremediation encourages the establishment and re-establishment of plants in an environmentally friendly way because it is achieved through natural processes. Much attention has been directed to adsorbent materials to be used in heavy metal removal from polluted water, and various techniques have been applied by chemical, physical, and biological techniques. Current data shows that lemon peels are capable of removing lead ions at a significant capacity. In my old science fair project, Fruitful Discoveries Part 2, 2020 to 2021, it has been proven that lemon peel powder can absorb 86% of lead from contaminated water within 30 minutes. My last year's project, Bioassay Test, Does Lead Affect Early Seedling Growth? Can Lemon Resolve It?, studied the percentage of seed germination and early seedling growth, which was affected at higher concentrations from 0 to 100 ppm. And it showed lemon peels help improve the early seedling growth from a high toxicity. Green gram seeds were taken for germination. Lead is a non-essential element for plants. Lead toxicity also causes swollen, bent, short, and stubby roots that show an increased number of secondary roots per unit root length. The physiological activities of the plant were negatively affected by increasing levels of lead concentration in green gram seedlings. At high concentrations, lead may finally result in plant death. This study was designed to use frequent available materials for removing lead from industrial wastewater. Lemon peel powder can be used to solve this problem. This research studied the percentage of seed germination and early seedling growth with different absorbent amounts in each lead concentration level and checking at what amount the seedlings show better growth. So one can decide the exact absorbent amount they need to use with each lead concentration. The testable question is, what is the best amount of lemon peel powder that efficiently helps early seedling growth in each concentration of lead-contaminated water? In this project, the hypothesis is the early seedling growth in lead-contaminated water will improve as the amount of lemon peel powder increases. The exact amount of lemon peel powder needed for maximum growth will vary according to the concentration. The purpose of the study is to find the exact amount of adsorbent needed for each lead concentration. To set up this experiment, begin by taking 28 petri dishes and lining them with filter paper. Place 5 seeds in each petri dish. This project used 20 ml of different lead concentrations, 4 sets of 7 petri dishes, 25 ppm, 50 ppm, 75 ppm, and 100 ppm. The adsorbent was added to the lead concentrations in different amounts, 0.5 to 3.5. Then this will be irrigated to the seeds in 3 milliliters in the next 5 days. The root length should lengthen, the germination rate, and the number of seeds with emerged leaves were noted, and morphological parameters were analyzed. The results were compared to the seeds that had no lead in their water. By putting more adsorbent in the concentration, it absorbs more lead from the water. This is because the greater availability of exchangeable sites or more available surface area. The effect of various parameters such as the vigor index, tolerance index, and phytotoxicity were studied and good results were obtained while using different amounts of lemon peel powder to filter lead from contaminated water. However, improvement in seedling growth beyond an optimum/perfect dose got slower. The perfect dose found in this experiment was 25 ppm 1 gram of adsorbent, 50 ppm for 1.5 adsorbent, 75 ppm 2 grams of adsorbent, and 100 ppm 2.5 grams of adsorbent. The results indicate that lead badly affects early seedling growth and can use the exact amount of good bioabsorbent for removal of heavy metals on a larger scale and create effective, cheap, and efficient methods in treating wastewater. Real-life application. This method can be used to benefit communities living in places where there is little electricity or resources to set up water purification plants, and people depend on contaminated water bodies for their needs in agriculture. This investigation may be useful to study plant growth patterns, particularly in areas polluted with heavy metals. Bioassays that use plants are effective, fast, easy to apply to any area, are cheap, and do not need sophisticated equipment to perform. They can also be performed in partnership with teaching institutions by providing specialized labor in the environmental area. The biomonitoring techniques do not replace the assessment of different parameters through the conventional methods, but they have a great usefulness for a first diagnosis of the monitored and non-monitored areas. It is suggested to the officials behind pollution control that they implement the use of bioassays with plants as a screening before the expensive physical-chemical analysis, in order to spare time and money, and that partnerships with private initiative and teaching institutions can build on the relationship of the world with quality of life throughout the terrestrial biome as regards to the pollution control and environmental presentation. Thank you for listening to my presentation.